Yes, perfect.
Glad to meet you.
Nice to meet you. How are you?
Thank you very much. How are you too?
I am fine, and you are most welcome to our webinar.
Thank
I know
you.
you are so busy, and we are so most lucky to have you in this webinar. And there are a lot of audience present in this webinar. I think today they will learn a lot of things in the area of computer visions. Hopefully, you will share many things from your experience. Thank you so much.
Thank you. That's very nice of you, and I appreciate it a lot. It's a great honor for me to have this opportunity to be among of such talented people. I hope that everybody can use of the content and it be useful for everyone. If you let me, I'm going to share my slides and start the session.
Okay, sure. We can start. Okay. And for the
Okay,
audience, I'd like to request all of the audience that if we have any questions, you can ask the question in the chat box. Okay. And hopefully our guest will answer sequentially. Okay.
okay. Okay, if you let me for a better connection and don't having problem in internet, I will turn off my camera. Is there any problem or
No
any
problem.
preferences?
No
Okay,
problem.
okay. Okay, I'm gonna share my slides. Okay, can you see my slides?
Yes, it's perfect. You can
Okay.
just zoom in. Okay. Full screen. Okay. I think it will be
Okay,
better.
yes, I'm gonna do this. Okay. Um, just a second. Okay. In the name of God, first of all, I want to say thank you and say again hello to everyone for joining this seminar today, or in better word, in webinar. In this talk, we are to exploring that how computer vision is no longer just about detecting objects and how language models are no longer just about chatting. We want to examine that how we can go through from classic computer visions to multimodal AI. We can understand that foundation of modern computer vision tools, YOLO, SAM, LLMs, and how we can combine these tools and features together to build the agent that's more than just read the text or action based on what we provide for them. They can collect information from their environments and can see the real world. And after that, be implemented on hardware on edge deployment, which is a very critical topic in the real world. Uh, First of all, I want to say that I want to review that's why this topic is matter now. AI has gone through a very visible shift recently. Everyone maybe noticed that there is a explosion in chatbots, in agenting systems. And if we want to review that, why this happens, we should say that without any exaggeration, LMs are extremely smart and they can understand very well. Uh, they can detect information. They can uh, connect different parts of our sensors data together and even act. But what we want to examine in this seminar, we want to understand that yes, okay, LMs are very smart and computer vision is very fast and powerful tool. But what we need in these days is combining them to unlock automation in real world, robotics, safety, retail, and even healthcare and beyond. If I want to introduce myself briefly, I should say that I studied electrical engineering, focusing on digital and hardware efficient systems. I completed my master at University of Tehran. Maybe you know this university. It's the first ranked university in my country based on US news. I graduated from Shariat University and got my bachelor from this one. My orientation was in electronic, and it was one of the best part of my academic journey. My focus in this academic path was on deploying different AI models on some embedded devices, for example, FPGA. My master thesis dedicated to implementing a stereo vision model that I designed it from scratch, and it has a very brilliant inference time. And yes, it was it has really good results, and I published a article from this idea, and it was very satisfying. If I wanna say about my professional experience from edge to agents, I started my working in Ag Telecom company. I was AI team lead, and I led deployment different models on edge devices, Jetson, Radixar, ESPCam, and one of our main focus was about decreasing the inference time. With the help of a refactoring pipeline, use of TensorRT, Onyx, and different frameworks. And our main focus, I should insist and say that it was using a state-of-the-art model. For example, VIT models and the model that's very off the shelf and had good results. On the other hand, after that, I followed my career as a C researcher and embedded AI researcher. I was working on ANPR engine, the model that its duty is detect car plates and extract information of it. I was able to improve its accuracy from 84% to 97%, which was brilliant result. And my current focus is building autonomous vision agents with N8Ns, N8N, LangChain, and other framework to improve and enrich my skills and combine what I learned in computer vision with this interesting field that are making everyone in every field create some models that can action rather than a human. Hold on. I want to check the connection and see that everything is okay. Can you hear me?
Yeah,
Everything is okay?
everything is okay. You just
Okay. I'm gonna continue. If we want to speak about the evaluation of computer vision, in the past we had different models that their focus was on image processing techniques, for example, edge detection, about applying different filters on images, and they were very good. And this is lots of time that we are focusing on them and working on them, and they help us a lot. And still, we're using them. But after a while, in these days, we have a very practical and more meaningful model, more useful. For example, with the help of deep learning, CNNs, VITs, provide lots of robust and learnable models that we can use of them in better way, and their efficiency are much better than previous ones. But today our goal is what? We want to have some machines that, like humans, can see and understand what is in contextual of an image, of a real-world problem, of a real-world accident, and on the other hand, be able to action as a system, as an agentic one that can be replaced by human. Is our final goal. Um, okay. The architecture shift, CNN versus SVIT. We mentioned and we talked about this kind of model in previous slide, and I want to talk about it a little more. As you can see, and you know, CNNs are one of the most powerful tools, and and what we find in these years to focus on local pixels, they help us a lot to understand the contextual of image. But with the progress of these models and with the help of transformer models, we were able to design some other one, which we call it vision transformer. We can split images into patches, and with the help of self-attention mechanisms, we can understand global context. We can focus on a specific part and understand what is happening in that specific and have a better understanding of that, which is amazing. If you have experience in working with these models, I'm sure that you are very eager to study more about this and use of these models more than before. Vision as the sensory layer. If we think in biological term, computer vision is the sensor system of an AI agent. Without computer vision, an agent is basically a brain in a jar. It's a popular idiom. It means that we have a model. It can understand, but as an agentic system. But without computer vision, without an eye, it doesn't have any connection to real world. So we have to provide some answer to fundamentals question that an agentic system asks us. For example, what is happening? Where is it happening? Who or what is involved? Everything else, responding, memory, action, and some other things depend on the first layer. If we can't provide some exact information from real world, our agentic system can solve this, can act in very useful way. Um, I want to have a quick glance to some famous models that we use in computer vision. Maybe most of you guys have heard about YOLO series. Honestly, they are king in this field, and maybe every computer vision engineer start with these models, and they are very excellent. They're fast, they're efficient, and if you work with them, you can understand and know that they are very efficient even on hardware. As I know that the most recent version, YOLO has different version, as you know, V5, V8, and even V10. And recently they are going to publish V12. I'm very ready to see this version because they pledge that it's going to be very hardware friendly. But if I want to show a simple demo of what does this model do, as you can see here, for some person maybe doesn't have any background in computer vision, it can see and detect objects in a video or in a photo. As you can see, it detects person, chair, and laptop and other objects in this field, in this video. And as you can see, it has very good speed and accuracy. But it's not idle, and it can be improved, and it is the reason that they are going to release another version of it. But it's a very powerful model. Okay, SAM. Another exciting model that if you're working in this field encounter with it a lot is SAM models. That's currently they released the newest version of this, which they call it SAM 2. I put some videos of this model here, and I'm going to show it. But if I want to explain that what does this model do, I should say that it can segment anything. It has been developed by Meta, and it can, with high precise and high accuracy, detect object. For example, okay, if you can hear, in the newest version, we can collect an object, and in very easy way, you can hear that, you can see that a car and a person here are detected, and it's segmenting them in very high accuracy. And in the below video, you can see that the user selected the ball, and um, in the left down video, the Sam was able to remove ball correctly without any lags or any effect of the ball. Can you hear it? Can you see this? I think it's amazing. This kind of
Yes, yes,
segmentation and
we're seeing this. It's really
yeah,
great. Yeah.
yes, yes. I think it's very interesting. Okay. Okay. But about object tracking, detection alone isn't enough for dynamic environments. If you process video frame by frame, the model forgets everything instantly. Tracking solves this by assigning identities and maintaining continuously over time, which is essential for behavior analysis. We have some problem in this kind of model. We want to have unique ID. We want to have ability to re-ID objects that maybe they occluded or they're going out of the frame. And when they come inside the frame, we want to find it again and say, yes, it was the last one. It was the same object that all of a sudden we didn't see in some frames. And it's one of the real problem that we are working, and it's one of the challenges in object tracking. Uh, what I explained is about tracking models, which I'm showing one of them in this slide. We have different famous models, ByteTrack, a strong sort, or some others, for example, a Stark, Fear, and lots of other ones. And their task is just detecting object, and after that, also I should mention that detection is not their duty. After a detection model that determine um, the region of an object, the tracker come and follow that object. It creates a feature map of that object, and follow that in the next frames. As you can see here, tracker is following the objects, and if it be visible, it assign an ID to them. But more than just detecting objects and tracking them, you maybe notice that this video has a low speed in tracking and detecting, and actually it's data. It's tracking. Okay. And tracking action, one of the most important things is real-time tracking. I wanna ask you to pay attention to this one. It is more real-time. It's very fast, and it can assign ID to objects and don't lose them. If you see here, it's very well for real-time application. So having re-ID, if we have same ID for the same object, it could be very helpful, and we can use it in counting object, about detecting abnormality, and lots of other applications. If you are starting to computer vision and you want to follow this field in a better way, you should know some fundamentals. You should be familiar with some libraries, frameworks, annotation tools. I should say that to build real system, models alone are not enough. You should know and be familiar. Sorry, there is some noise. I can hear some voices. Is there any problem?
I think now it's okay. I mute the other
It's
guy. Okay,
okay.
guys.
Okay, I was hearing some noises.
Everyone, please mute your microphone. Okay.
Sorry, I couldn't hear.
Okay, you can continue. You can continue.
Okay. I was saying that if you want to start computer vision engineering, you should be familiar with some libraries, frameworks, annotation tools, and building a full system and full pipeline won't be happening without these tools. Uh, for the first one, I should say that OpenCV is one of the most popular library that you should be familiar. PyTorch, TensorFlow are some frameworks that in every aspect of AI field you should be familiar with and be expert at this field at them. Other frameworks that dedicated to this field are Ultralytics, that their main focus is developing YOLO, and Supervision, that they develop Rufalo's models. I should say that these days Rufalo is one of the top-ranked frameworks that are developing different models. And if you are researching in this field, I suggest you that try different models that they released recently. And for annotation, if I want to explain what I mean of annotation, you need a data that has good label, good information. That's, for example, this object is located in which part of pixel, in which part of picture, and some other information that you can some other application for creating and providing this data. For example, RuboFlow and CVAT. So, despite all the progress, computer vision is still hard. We spoke a lot about different powerful model, different progress, but actually we have some problem that's currently in these days. If you ask with every computer vision engineer, will explain you that yes, we have some problem in occlusion, about lightning, about noise or blur. Uh, as you can see in this slide, I use of a photo that I posted recently on my LinkedIn, and it gets lots of notice and it become viral. As you can see here, due to lightning and some kind of noise that we had in a picture, we wanted to detect information of a plate, and we were unable. If it be clear, maybe it should zoom on it. At the first, we have this image that yellow detected result was CU22Q69. As you can see here, the zero number wasn't visible. And after some pre-processing, it was more clear and obvious, and yellow could be able to detect results in better way. So these are some kind of challenges that if you start working in this field, you're gonna encounter. And yeah, these are very hard, and although they're fun, you can use up different tools to overcome these challenges. Okay, next part, one of the interesting parts are the LLM revolution. Um, Now let's switch to language models. At their core, LLMs predicted next tokens, but at massive scale, this simple idea become powerful reasoning behavior. What recently changed is not just language understanding. We have a serious change and shift in this major. More than just having a language model that can speak with us, talk in text formats. We have some models that can reasoning, that can analyzing at if we let them, they can act like a human. Maybe most of you people, or lots of you, be familiar in this field, and you be aware of different state of the art LMs. For example, GPT-5, Cloud, Gemini, or maybe some of open source. Maybe you worked with them, Llama, Mistral, Kiwin. But there are different models that can help you, and you can use of their maybe in closed source API key, and in open sources you can run them locally on your device and start simple tasks with them. For example, chatting with them, analyzing some data, and do whatever is text-based. Models are getting smarter and cheaper, and it's one of the best part of this field. Um, if we want to speak about LLM limitation, we should say that despite their intelligence, LLMs have fundamental limitation. Maybe you have experienced that you're chatting with ChatGPT and hallucination happens. It answers you some things that they are not real answer. You are not looking for this one. They doesn't follow reasonable response, and you can understand that uh, the response that generated for you is not true. It's false. It's one of the limitations that LLMs has. And on the other hand, they in lots of cases, in at least previous models, they had no grounding. They didn't know that what is happening out of their system. Nowadays, if you have experience working with, for example, Gemini 3 or Grok or GPT-5, uh, they are able to detect what you are sending for them. It's image, it's video, it's PDF or whatever, and can connect this information together. But without them, they have no grounding. And in most cases, and actually in previous versions, we had text-only based models. They cannot see errors or environment directly, and it was one of their most important challenges. Um, at a glance, we can say that the LLM engineers toolkit that um, everyone that want to start this field should have in their backpack is to know prompt engineering, how to creating some prompts that be clear and obvious and make models understand what you want and answer you correctly. And context window management, handling memory. Maybe you've experienced that you're talking with a model and it says, okay, I don't have enough memory, you should start another chat and you should manage this. And RAG systems, retrieval augmented generator, which are one of the most important and practical tools in these days. You are connecting external data and you're gathering lots of information together to examine what is happening, for example, in your database and answer your customer, your user, that what you want, let me check, let me retrieve, and they are very useful and they're an explosion wave. There's lots of tools, OpenAI API, Olama, Hugging Face. They are very practical ones that maybe you become familiar with them. Vision language models, VLMs, image plus text understanding. I think this is where things get interesting. VLMs convert images into representation that language models can reason about. This allows us to talk to images and not just label them. As you know, and maybe work with this kind of models, VLMs process image by converting them into tokens in maybe in vector, and LLM can understand them, and they make us able to understand what is happening inside a video, inside a picture, and they are very interesting. Key players in VLM. We have some famous models for this. Clip, Lava, GPT, or Gemini version, as I explained before. They're very useful, and some of them are open source. But for using, you have maybe have some strong hardware, but this is not our focus in this part. But they are very interesting. I want to show some example of these models. We talked about YOLO in previous slides and about VLMs. Can you, I think there's, no, okay. In left image, we have a picture of two cats that lying next to each other. Vision component is what we have in right side of this bar. We have this picture, we can feed it to a YOLO model, and it can, for example, detect two cats. But on the other hand, we have language components. It can describe for us that what is happening inside this picture. And in the right one, which I wanted to show in this slide, this one mistake. You can chat with these images. For example, if you can see, can you point to the front right paw of the black cat? And if I zoom on the image, you can see that, yeah, front right paw of the black cat is just pointed. It's very interesting, and it could be very useful. It's the most powerful feature that VLMs provide for us. Um, if we want that why VLM alone is not enough, we should say that we have some limitation in VLMs like computer vision models, like LLMs, and every other fields. Latency is one of the most important challenges. VLMs are slow compared to real-time CV. We want some models that be very fast, that can treat in real time, and with low speed, they're not going to be useful for us. And they describe what is happening in the images or videos in this case, but they can't act. The main thing that we are following this in this webinar to understand that how we can enable these models to act in a better way in real world. And they are disconnected. They can't access database or tools without wrappers. If we provide for them some database and they be able to connect with them, they can do some most interesting tasks. If you let me, okay, what is an AI agent? LLM, tools, memory, and agents. It's what we wanted to have and speak about. Um, Difference ChatGPT answers questions and agent accomplish goals. When we have LLM, when we have tools, when we have memory, we can get help of our brain, our hands, and our context. When we're combining this information with these tools, these reasoning applications, reasoning tools, we can have agents that is very humanized and can be replaced with lots of maybe our colleagues even. Okay, from chatbot to agents. This evolution is important. Chatbots talk, RAG system talk with knowledge, agent act in the real world, which is the most important and useful action in these days. In this slide, I want to show you that how agent loop works. Maybe some of you be expert in this field, but for someone that doesn't have any background in this, as you can see here, it's very simple flow. We can see that agents operate in a loop. They perceive, reason, act, observe the result, and adopt. This feedback loop is what enables autonomy. We can have a loop that always is working 24 hours in a day in 7 days, and it could have very low errors. And with the help of perception, reasoning, and some other features, it could be very practical too. As I explained, you know that agents matter a lot, and why this high? For business application and industries, this means automation of complex workflows. Agents are not just faster execution, but fewer errors and continuous operation are one of their advantages. Yes, they can work without any tiredness and can be replaced with lots of humans. They have some ability. They can trigger an alert or a system with just sending just simple JSON. For example, you can have a system that it feels that we need to send an email to our safety officer. And with its ability to writing different kind of models, for example, codes or JSON or different formats of database, they can generate data, and if you let them, they can trigger different modules. The unified architecture, vision agents. Um, this is the final step that we wanted to explain. When we have a unified architecture, we have a camera that it gets a stream from real world. For example, YOLO as a fast computer vision model can detect objects, and after that, it will transfer to VLM. It can reasoning and understand what is in that video or image. And on the other hand, we need a decision maker. We need action. For this part, we are going to use our agents. And we in next slides, we want to examine some example of this. Before proceed, I want to check if there is any question or any problem till here or no.
Yeah, there are some questions. I think we can talk after the slide. What do you think?
Okay, so let me, I'm curious about watching. Okay. We're going to answer this question at the end of the presentation.
Okay.
Okay, this is one of the interesting examples that I like to examine. If you see and focus on the left image, for example, in football analysis, hold on a second, sorry, my phone is ringing. Okay. We have in a football analyst agent, we can have a YOLO, for example, detect players, that it can detect players and the bots. If we have events that are suspicious and or maybe aggressive, we can use of the videos that camera streamed from the playground, and we can send them. Oh, there was problem or no? Okay. We can send them to a monitor room, and we can examine this. Nowadays, we are using in this way. But next, the tracking system with re-identification kicks in, and it doesn't just detect players; it assigns persistent identities. So the system knows which specific player was involved. Not just someone did something, but know exactly which player at which moment and what is its history. For example, player number 10 had some suspicious activity and maybe body contact in the game. And our model, our agent can record this and save this in our database. When some similar happens, our system can detect it, and on the other hand, can check it at real time. It will send this data to VLM and analyze the scene and answer these questions. Our agent can ask that what exactly happened, who initiated the contact, where did it happen on the field, or some other question, for example, does it look accidental or intentional? The analyzed output is then passed to two places. It will go to database and AI agents. Maybe our agents ask more questions. For example, ask of LLM that zoom into the contact area, describe the interaction step by step, or some other information. For example, compare this action to previous faults. And the agent may also query historical data. Has this player shown dangerous behavior before? Is this a repeated pattern across the match or previous games, or some information related to that specific player? Based on this combined reasoning, visual evidence, and some other information, historical context, the agent can decide to trigger an action. For example, it can send an alert to the referee a smartwatch. It's another one and another way of explanation which I am describing. For example, player number X has multiple high-risk interactions. It has been recorded, and this incident is suspicious. It can send a message to referee that VAR review is recommended. At this point, the system is no longer just seeing or describing. It is observing, reasoning, and acting, all grounded in visual evidence. This is what a vision-enabled agenting system looks like in practice. Imagine a suspicious situation happens during a football match or in another environment, for example, in industry or in usual environments, even in street, outside of our house, and even inside, detecting abnormality, and we want to store this data somewhere and not some other one, maybe our host or some are responsible for this, and give them some alert. They can be very useful. Okay, case two is one of the other interesting examples. Maybe you see some models that their duty is detecting, for example, a person has helmet or vest or some safety measurement before, for example, entrancing a place. As you can see here, we want to check that a person have safety dress, for example, and after that, if that person has those ones, we let them enter, for example, to a red zone. In this picture, we can see that, for example, yellow detect person in red zone, check for safety vest. If that person will wear that vest, VLM can confirm that, okay, you can come in. And without that, it can save data in our database. It can record and set alarm. It can notify some other one and maybe turn off some systems, because in industry we have some devices that maybe they're running be very dangerous, and for for this reason it can act in a safe action. Building tools. To build these systems, we can use different tools like N8N, agent frameworks like LangChain. If we want to use of just systems that we don't want to coding, N8N, Zapier are very good. But for complex and custom logic in Python, of course, that LangChain and LangGraph are very better one, and they can give you more flexibility. And for handling video streams and zones, we can use of supervision. The role of memory lag in vision. Memory is critical, as we know. Vector database allow agents to remember past events, faces, or patterns, enabling long-term reasoning. For example, I can remember that in one of my projects, we wanted to develop a system that in a shop, when a new customer comes, the camera detects their face and get a print, get a, for example, something like fingerprints, but based on their face. It was a face recognition system. And save them in a database. And the next time that customer come to that store, it says that, hello, yeah, I know you. You are, for example, person with their first and last name. And recommend them that if you are interested in buying some stuffs that you bought at last time, I can recommend this kind of tools to you. And agent needs to remember some databases like ChromaDB, Pinecone can store image embeddings, which are very useful. And when in this example, a new person comes, they should be able to find a specific person across dozens of patterns and peoples, and act in real time. But one of the most important part of AI, I think, is this part, the hardware reality check. When you are working in AI field, you probably encounter this problem that demos are easy on cloud GPUs. When you have very expensive devices, you can run different models in very practical way. But the bottleneck of AI, I think, always is embedded AI or edge AI. When you want to run a model on edge devices, for example, Jetson, Raspberry Pi, and especially when you have a combined model, for example, you want to use a computer vision model. Beside that, you want to have a VLM or RAG. This is very critical issues. You should be able to run this model together on a, for example, low power and low price device. Because in industry and in business, uh, the people doesn't like to have very expensive tools that can work very well. They want always to have a very effective tools that can run me on very cheap models, and it's a trade-off that you should be able to have high accuracy but on low power and low cost devices. One critical challenge: latency versus accuracy trade-off. As you can see here, we don't need GPT-4 for every frame, and 95% accuracy at 30 minutes, it's FPS, is way and much better than 99% accuracy at 500 milliseconds. It should be mentioned that our real-time performance is very important, and if we are not able to provide this kind of models, maybe customer doesn't like to buy some stuff of us. What we are developing, it should be used and be practical in real world. For optimizing and making your model deploy on different devices, you should be aware and familiar of different techniques. For example, quantization, pruning, or different frameworks. For example, if your target device is NVIDIA, you should be familiar with TensorRT in computer vision or even in LLMs. Quantization is a technique that you can convert your weights, your bias, your activation functions, and what you've saved as, for example, .pt formats in different formats. For example, if it's in floating point in 32 bits, you can convert it to 8 bits in integer formats. And in idle situation, you're gonna have 4 times faster and a smaller model. But in real world, it's not like this. It's an approximation. If you've done before, you are familiar and you know that it's not completely true, but it can give you a very great boost. And in next step, pruning. Pruning is removing unnecessary neurons. You cut some of neurons and their weights and what belong them to make your models lighter and also preserve the accuracy. It's very practical. But with this current version of, for example, Onyx or TensorRT, they are doing this on themselves, and maybe you are not have to deal with this kind of pruning. But in previous version, it was very practical technique. TensorRT, as I explained, is a tool that can convert your model in a format that be compatible with NVIDIA's system. For example, embedded GPUs or their graphic card, and it can increase your inference time very well. It can parallelize and use of different components on their devices, and it's very practical. Okay, edge hardware landscape. In this slide, we are reviewing some important and famous devices. NVIDIA Jetson, Ori, Nano, there are different versions of NVIDIA Jetsons. They are standard for Edge AI. Maybe partially they are expensive, but their performance is very great. On the other hand, we have Raspberry Pi, Hilo, or in this current version, we have a Chinese board that is called Radixa. They have good for basic tasks, and if your target device has NPUs like Radixa that I mentioned, they can dedicate AI chips in modern processors and treat in very close to NVIDIA Jetsons. I've experienced in deploying different models on this kind of devices. Their NPU are very strong and can accelerate your process very well. Okay. The cascading solution. You should be able to run YOLO very fast in real time, at least 30 FPS, and you should be able to trigger if interesting event, for example, an abnormality or something that you should investigate more, and run VLM. It has some problem. It's slow, but it can reasoning. And at the end, you should have intelligence and speed. And final result should be an action that you be able to treat in a very reasonable way and act in real world. Uh, Future trends, if you're interested in this field, I think, in my idea, and as I study in this field, I should say that the future belongs to people to have the ability to combine and set all of the features, for example, SLMs, active visions, and different kind of sensors even. We can say that if you be able to put these tools together, this kind of data together, uh, you are winner in the future. The future challenge and race is between the people who can understand the fundamental, for example, in computer vision, LLMs, agents, or every other fields, and deploy them in a very effective way. And there is some other concern, for example, privacy, for example, latency, and some other ones that partially they're related to your device, your deployments, partially related to your model, and different aspects. But the most important, I think, is ability to setting these features together and make them work. It's very important, I think. Your career path, if you want to start and work in this field, of course, you should know Python, Docker, Onyx, basic LMs, integration, and the knowledge of a full stack AI engineer. Honestly, I don't like this exact word. I prefer some other ones that you should be able to provide end-to-end model. You should be able to deploy them, and you should be able to use them as a workflow, as an agentic system. It's the final goal that you can consider for yourself in your career path. And yeah, it's the final part of our speaking of our webinar, maybe. I can say that vision gives you eyes, LM give brains, and agents give hands. These are information that you can connect with me, my email, my LinkedIn, and I'm very eager to connect with you. And it's a great opportunity for me to have this time and be among of you people. Okay, if you can hear me, I can stop presenting, and I'm here to read your
Thank you so
questions.
much.
You're
Thank you so much.
welcome. You're welcome.
So I hope everyone enjoy your discussions, enjoy your knowledge sharing sessions. It's really insightful. And hopefully we can start the FAQ session. What do you think?
Sorry, I can't hear your voice correctly. If you can
We
hear, can say.
we can start the frequently asked question, okay? So we got some
Okay.
question. Okay.
Okay. If I'm right, we have
Okay,
some questions in chat box, and some questions were asked in the group and in my direct. Which one we prefer to start to answering?
I think we can answer the first question in the chat box. Okay. Okay.
In the chat box. Okay. I'm gonna check this.
So
From the last one, can segment anything model perform well in limited number of medical images? Segment anything model perform well number. If you mean, I'm answering. If I pronounce correctly, Omi Hassan. Hi, Mr. Omi Hassan. If your question is about that you have a limited number of data sets and you want to train a model and you want to give a high accuracy of these models. Honestly, I should say that one of the challenge most critical and challenging part of training a CV model is collecting data. You don't have any risky way. You have to collect lots of data in different variation and then start to training your model. I can remember for one project that I was working, we had about maybe 500, I don't know, below than 1 million images. But with that much of data, we had still problem in detecting objects. We had to augment, we had to decrease the number of data, and although I should say that it was very complicated project, but what I want to say is that you need very massive and different data to cover different kind of your images. For example, in your medical image, you need to have different kind of, for example, in cancer images, different size, different resolution, different lightening to enrich your model, enriching its skills to detect in better way. Okay, the previous one, please share the web report. Okay, we will share. Again, slides. Okay, I can share you the slides in my final year dissertation. I'm working with diagnosing diseases from medical images using VLM in my local language. I'm using VIT and BERT models to train my model. How can I increase my contribution except building a custom dataset? Is my and merging multimodal datasets. Mr. Huda, if I'm pronouncing it correctly. Maybe it's your question is similar about dataset. You're asking that how can I increase my contribution except building a custom dataset and merging multimodal datasets. In this specific field, I'm not familiar and I don't know that how you can collect different data. But as I know, there is lots of pre-collected data that you can use. For example, in my master thesis, I can remember that my focus was autonomous driving. And for this, we had different data sets that they were free, that they had a standard benchmark, and we were allowed to use of them. Maybe if you check RoboFlow, different sites for, I think, for some university, I can remember their name right now, maybe they provide this kind of data set for you. But if your data are very they're focused on a specific area, you should try to augment them. You should try to regenerate some different image and more data of them with the help of generating models. There are lots in use and you can use of them very easily. I think it's gonna solve your problem. Another question. My question is, I am doing bachelor in 4 years, doing my major in electronic and power section. Can you give a rough roadmap to do my master in electronic, especially on the hardware based? It's a great question. Honestly, I'm answering Simanto students question, if I pronounce correctly. If not, I apologize.
Yeah, you're
I
correct. Go ahead. Go
Okay.
ahead.
Okay. Okay. I can remember that when I was studying electrical engineering, one of the most interesting and exploding field was AI, and about 10 years ago, or 8 years ago at least. And all of us had the same question: that how we can converge to a path that combine this kind of electrical ability and skills and lessons that we've learned in university to this section. It was very interesting part. I should say that we started to studying courses. I started with deep learning and neural networks. And at that point, I understand that's okay, how I can combine my knowledge in electrical and AI together. There were lots of ideas. For example, in my master, I was following this idea, and in my master thesis was about stereo vision models. I wanted to detect 3D information from real world and develop a model and deploy it on a hardware. Because my orientation was digital systems, orientation from electrical engineering, and it was very important for us to have ability to work with this kind of devices. So my focus went in a way that I want to develop a model that show my ability in designing a model from scratch in this specific part, in this specific field, and deploy it. I'm electrical engineer. I should have hands-on experience in working with these devices. And if you search more and consult with your, I think, professor, your thesis, your supervisors. Your supervisors, you're gonna find the solution. It's a challenge. It's a common challenge in entire world that I encountered in some years ago. I think you're gonna be successful, and always there's a solution for combining this fields together. In each field, we are combining AI. Um, AI is very close with electrical engineering, undoubtedly. Okay, the previous one is a long question. My question is, I have a dream to make an AI assistant which I can use in football team. Very well, I'm working on a project that its focuses on football plays and games. Where you can use every player data like their skills, their weak zones, also how to improve their weak zones through their data. Where it can use on training session, and also I want to roll it for real-time data analysis. Yeah, I'm using it on match day where I'm gonna use this thing on opponents players to study their weak points and attack on the field based on them. Also the AI assistant can give me information based on those data, how to pick up. Is it possible to make this? I want to know the impact of computer vision in this case. How can this help? Honestly, I'm working on a project that is examining this kind of data. You have to know different fundamental in computer vision. You have to deal with different data, for example, some fundamental, that's what is SQL, what is database, how you can handle and how you can transfer data, how you should record this information. And I should say that it's very interesting field in different clubs on entire world. Lots of people, lots of person that their focus is data analysis are working on this kind of data and this kind of project. Yes, it's possible, and but I should say that it's very challenging field, but very interesting. One of my favorite sports is football, and because of this, I try to use a football example in my slides. And I should say that yes, it's possible, and myself, uh, for myself, it's very enjoyable project. I think we can work on this kind of data, and it has lots of customer, and there is lots of club that want to buy you this kind of tools.
Can I ask you a question?
Yes, yes.
Which team do you support in a football base?
Honestly, I can't understand what you told. If you
I asked you which football team, which football club do you support in
did you
your country?
in my country or abroad?
In European competition, to be very precise.
Uh, I'm fan of Barcelona.
Man, I'm so sorry. I'm kind of disappointed, but for a biggest rival of football.
Okay, okay. No, no, I watch football for its pleasure. I'm not very. Uh, I don't look at this sport just like a fan. I enjoy of this.
Uh, to be very honest, for men, boys like us, it's a one club, one country, one club sort of
Y-
thing.
Yes, you've dedicated your focus to just one club, but no, we try to watch football as a sport and enjoy of this.
In
Uh,
football, there is called passion.
Excuse me, can you
Yeah,
please answer the other questions? You're
yes,
now talking about some non-technical discussion, so thank you.
yes, yes. Okay. Uh, okay. Some common frequency. Oh, okay. Hold on for a second. I should check some
Yeah,
connection
can I
here.
ask a question? Like I have some normal things to ask you. Can I go ahead?
Yes, yes, go ahead. Yeah, you
Yeah,
can ask.
yeah, yep. I have a question with respect to re-identification of object or else person whenever they come across into the frame multiple times and they leave the bay and reappear. So with respect to
I'm so
re-identification,
sorry. I'm so
yeah,
sorry. I'm so sorry, but I can understand what you're saying. If you do fever and write in chat box, I can read it clearly and I will answer. I'm so sorry. I can't hear very well.
Okay, Mr. Kiran, could you please write in
yeah,
the chat
sure, sure.
box?
I will do it. I will do it.
Thank you.
Okay.
I'm so sorry. Okay. Some
Okay.
common
Um,
frequency as question in what did you tell? Did you say something?
yeah, we have some other questions. You see,
Yes,
I
yes, yes.
just
I'm going to answer them. You wrote that in computer vision application, we need high configured resources. That is costly. So, as a learner, how to develop application with low costs? No, I think for starting this field, for starting to become a computer vision engineer, it is not essential to use all very expensive resources. There's lots of free resource, for example, for running your codes and getting help of high performance devices, for example, GPU or even TPU. You can use of Google Colab. It can provide for you some high performance devices that you can run your model on them. And on the other hand, there are lots of notebooks that you can use. And most important, there is tons of trained model, pre-trained model. You don't need to train some models from scratch. That is very, it has lots of cost and took a lot of time. For example, some of model that I showed you, YOLO, SAM, or even mobile nets that have already been trained on millions of images. And you can simply fine tune them on your smaller dataset. And on the other hand, and in final step, you can use of Onyx or TensorRT, which I mentioned in my talk. That they allows you to run lightweight models incredibly fast, even on cheaper hardware. So you don't need to use of expensive devices. In another question, you asked that to be civil engineer. Hold on. Do we need to strong core knowledge of computer? I'm writing correct question, yes. Strong core knowledge of computer vision and deep learning. And the answer is both yes and no. Look, now we have the knowledge of mathematics and scientists uh, for every field. But when we are coming in a field as a scientist, we have to invent new algorithms. For example, some deep theoretical knowledge. We need that develop some fundamentals. But when you come as an engineer, however, using existing tools, you can use of pre-trained and provided tools in real-world products. So I think you don't need to master all the theory on day one. you should, I think, start by learning practical PyTorch and building a few projects. When you hit a wall and you encounter a problem, you can go back and read the theory that is your demand. This makes learning much more effective, I think, and rewarding. So don't be afraid. Just start building, and you're gonna be expert on maybe in both sides, in mathematics, in fundamentals, and core knowledge, and in engineering. You asked that what kind of skills they would need to become a civil engineer. I try to cover this answer in my slides, but if I want to summarize, the skills fall into four or five categories. I think you should be a programming engineer. You should know how to write a code in Python, which is the king in this field. On the other hand, you should know fundamentals. For example, what is object detection, tracking, what are the most famous models in this field. And I think you should know how to implement these models. For example, someone use a PyTorch, someone use a TensorFlow framework, and based on your demand, you should choose between these frameworks. And in last part that I emphasize on it always, I should say that you should know that how you optimize your model, how you deploy your model. Learning Docker, Onyx, TensorRT, and some other tools can make you end-to-end engineer and very professional AI engineer. You asked that what kind of I answered this. What's your daily routine as a civil engineer? My daily routine, my personal daily routine, or engineering? It's an interesting question. Honestly, based on my interest, I'm always studying and reading about the new project and new development in this field. I should say that I love to study articles and contents that someone who are famous on LinkedIn are publishing. It's one of my favorite parts of my days, and beside that, I have to train different pipelines to work on different models, and have different meetings with my colleagues that we want to debug some models, add some features, and we are trying to develop different model when we are involving with project in computer vision or other fields. You have to be keep in touch with your team, and every single day you try to be aware of what is the trend news and what is the most upgraded version of models, and you should adopt yourself with them. So I think one of the most important of computer vision, or actually general engineer in every field, should be this part. Another question: is there any scope like GOT allowed to work remotely from Bangladesh in Iranian company as an AI engineer? To be honest, I should say yes, there is, but I don't know them. I know that exists, and some of my colleagues and friends use of them, but I think a better solution is working on your LinkedIn profile. I've heard some time ago that from a famous speaker, he was speaking that LinkedIn is a very practical tool, and it's a gift that you have already, and you can use of it in a very practical way. If you want to spread and boost your personal brand, you can present yourself as a very professional engineer. You should focus on your LinkedIn. You should try to connect with different people. You should show your ability, and I think in that place you're gonna have a better connection and better opportunity. So honestly, I've never focused on this kind of I should say what kind of this application and websites. Rather than I always been focusing on my network and my company that are located in my country. But I think the best choice is LinkedIn. Each company's model is best for building agentic AI. It depends on your demand. We can say that um, actually there is no best model. There is only the most suitable model for your specific tasks. To choose depend on three factors, for example, or two factors, maybe cost, maybe performance, maybe privacy. Some of them are very expensive. Some of them are free but slow. Some of them the hallucination and can't answer you properly. There is some websites, for example, I've been using Open Router these days. It provides for you some API keys that you can use for starting some free models. It can be a good starter point, but for most advanced application, it depends on your demand. We can't select one. And is there any other question?
Yes,
How can some other
there are new 3 or 4 questions in the down, go to bottom.
okay. Okay, I'm gonna check them. Do you think doing a PhD is more important or joining engineering companies important for contributing to engineering future? It's very important question. I've been at this dilemma about 2 years ago. If I wanna tell you a short story, I was not sure that I should pursue PhD in this field or I should start engineering. At that time, I applied for different PhD positions and I accepted one, but for some reasons, I was unable to join that university and start my PhD career, and I had to postpone this aim for a year. And thanks to this happening, I had to start my engineering path. So nowadays, I think if you want to be a academic person, you want to be a professor and see yourself as a professor in university, you want to do research. Of course, you should pursue your PhD. But if you want to have a hands-on experience, you want to work in real world, an industry, maybe working on real projects and engineering world be a better option. But I think it's depend on yourself. If you prefer researching without any hesitate, just pursue PhD. You're gonna enjoy it. But if you want to have vast experience in different sides, I think engineering is very interesting. I'm enjoying it. Yes, I can say this. We can talk about this question for long hours. Someone asked that with respect to reality, how could you suggest to work on it when a person lived the book and repair sometimes, and what are the processes we use to remove the shadows and make Mr. GD, if or Mrs. I don't know. About reality, we have some models that they are very powerful in this field. For example, if I remember correctly, we were working on a model which its name was Stark. It was very powerful when you detect the object and asked of this model to track. It creates a feature map, and if that object become disappear, it was occluded, it went outside of the frame, and it returns to the frame. It could understand and find it very well with the help of vision transformer layers that it has. It could find it and follow it again. But we have some other algorithms, for example, a Kalman filter. You have a Kalman filter that, for example, in football, when a player kick to a ball and that ball run in a specific speed, it can predict that with this speed, this ball is going outside, or maybe change its position in different frames. And it can, based on its prediction, follow that object. For example, you can understand, okay, we don't have this object in this current frames, but I think in about, for example, 10 frames later, we're gonna have it. So it focus on it and it will wait to find it again. It's very practical and it's very useful in aerospace project. I can remember that's in one project we were using of Kalman filter and it was very useful. And what pre-processing? Pre-processing, if I remember, I posted this content, I think 2 months ago, and on my LinkedIn, and you can find it on my profile. I think I tried different algorithm and pre-processing, but finally I converged to Kelahe and another one, but I can't remember right now. But it's depend on your demand. You should examine that your model work with which model in the best way. I examined, for example, I think more than 10 filters, and finally I understand, yes, these filters, they were two ones. They were very effective, and I used them in my model. Hey, you mentioned in the beginning about your research work where you said that you have been working on vision transformer deploying on FPGA. I said that I worked on stereo vision models deploying on FPGA. Can you please briefly answer that? Which method did you use for that? Did you use any compiler for this? Yes, yes. I'm very pleasure and happy that there is some person who knows Fiend, why to say, oh, these are very practical use in the FPGA field that I spent lots of time to learn them and work with them. Yes, yes. At that time, I used both Vitus AI and Fiend, but Vitus AI, due to its lack of support of some devices, if I remember correctly, it's about 3 or 4 years ago. I think, yeah. Finally, I converged to Fiend, and I designed one model that's be hardware friendly, and I published an article of it, which you can access on IEEE site. And I've mentioned it on my LinkedIn profile too. And its hardware implementation performed with the help of Fiend. Yes, we used of that. I want to build an autonomous or semi-autonomous car as an academic project using ESP32 CAM module. Is it possible to run a computer vision model on the ESP for the project, and what process steps and components are required to implement it successfully? Yes, ESP CAMs are very simple, cheap, and unbelievably powerful devices. I worked with them. I should mention again that in another post you can find what I've done on ESPCAM for reading some what's his name? Reading some analog and digital numbers of different contours. Listen, there is lots of pre-trained model that you can use and deploy them on ESP. But if you want to implement a custom model, I think one of the easiest choice is MicroPython. If you are familiar with this tool, you can go for it and try it. But due to low low amounts of memory or processing ability, maybe ESP is not the best choice. If you can provide more powerful device, I definitely suggest that don't take time to deploy your model on this device. Although I recently I didn't work on this kind of variation, but I've heard of one of my friends that work on this field that they are developing some tools, and in new versions of this device, they embedded different parts for processing neural networks, and their performance boosted a lot. I'm not quite sure, but when I was working with it, yes, MicroPython was one of the great choices. But I suggest you, before starting to perform any engineering task, do a very great research. I was developing a model for reading numbers from gas or water meters. And finally, I found out that there is a pre-trained model and deployable model on ESP. So my pass was very short, and lots of effort are removed of my my plan and what I wanted to do. How we can develop an optimizer? Why you want to develop an optimizer? For what task? If you want to develop an optimizer to deploying a model, there is pre-trained and provided tool for this. Because these optimizers, honestly, well, how we should explain this? When you want, for example, run your model in Onyx runtime, Onyx runtime is a framework that lets you run your model in a way that's be effective, that's be able to convert to different models. And in this specific framework, you have a specific requirement. You should use of optimizers that it can support. For example, in Onyx runtime, you can just convert it to Onyx, your model from, for example, .pt version, and it will apply all of the optimization techniques without no effort. Why you want to develop an optimizer? If you have specific target device or a specific framework, or maybe you are developing a framework, I don't know. We can speak about further, but with these current ones, you don't need this. But if you want, you can start from quantizing, pruning. Quantization is one of the most practical way that you can shrink your model. So yeah, I can remember that in one project in our university, one of our professor was focusing on this part. He wanted to design an optimizer for a specific version of FPGA, and we were consulting about this, and I didn't follow that project after that, but it could be interesting, but you should examine your purpose very well. I've compared with unit. Let's check. Can segment anything well. I have to process the image from the number of images and good accuracy of a segment anything model is it's low. I compare with the existing state-of-the-art model. Yes, I have compared the units, transients, and those models performed with. I think for this, you should examine different approaches. One of the most important ones definitely is data. But on the other hand, you should examine that how much your model is performed good. I mean, in my master thesis, I had a model, the one that I developed from scratch, that's how much I added different layers and used of different, for example, optimizer, different loss, and different configs. I get different results. And one of the important ones was adding some layers and making it deeper model. When it becomes deep, or even using more powerful layers. For example, if you're using CNNs, you can convert and switch to VIT. But I should say in parentheses that VIT are very hungry data. You maybe need more data rather than CNN ones. But you can use of different layers and different architectures. It can help you. Where is that? Okay.
Okay, Joker, Mr. I think your name is Joker, right? His pronunciation is okay.
Yes, my name is Mahdieh Jokar. Yes, it's
So one of my friend joined from the Japan. He's doing PhD. So he asks last question to you. Could you please answer?
mm-hmm.
It's a plus.
Yes, he's Mr. Al Amin Sheikh. Am I right?
Yes, yes.
Yes,
Yes,
you're right.
okay,
Thank
I'm
you so
gonna
much.
read.
Yeah, please.
Yes, okay. Could you please briefly mention which platform and open source datasets are suitable for beginners to learn and build AI agents? Thank you. I see. For AI agents, I think if you know how to code, you can start with different frameworks. For example, you can examine what is happening inside a rack system, what is happening inside a LangChain. But on the other hand, if you don't want to focus on coding, N8N or Zapier are very practical tools. And I should say that without any hesitate, you should go to YouTube and search deeply and find the best one. There's lots of videos that can help you to start, and I started with the help of them. And yes, and second question, for biomedical research, which AI agents are most useful for analyzing biological data for medical imaging and multi most useful. Honestly, it's very specific question. My focus wasn't on biomedical research, but I think with the spirit of creating AI agents, it would be great to maybe one of useful choices be using and creating an agent that be customized for your model. For example, some of models are best in detecting images, or some of them are very powerful in reasoning. And depending on their ability and your demand, maybe you should try to build someone based on your requirements and demands. But it's very specific question. I'm not totally aware in this field.
I see. Yeah, actually, sometimes we got lots of data sets, such kind of image. So based on those images, like we can perform maybe some machine learning application by using CNN or something. But to make some AI agent is quite important, I think, because if we can set up some AI agent, then it can be automatically detect and automatically set up their informations. So that's why I was a bit wondered about those kind of things. Yeah, I'm not much familiar about like AI agent or machine learning yet, but I'm trying to learning. So yeah. And how about like multiomics? Do
I have
you
one
have
suggestion. I have one suggestion that
okay.
you can use the latest state-of-the-art model of the unit, like
Yeah,
NN unit,
yeah. I
and
heard that.
implement the NN unit with the help of LangChain framework. Okay, as in this case, because it's a you will work with the complex data set, complex ecosystem. So in this case, N8N JPL is not the suitable one. So you can go for the LangChain and build some ecosystem for the vector database and integrate the unit model. I think it will be help because unit is frequently used in the biomedical research.
Okay, got it.
Okay. If there is any other questions, I'm here. If not,
all are
we
done.
can.
You can close your
Mahdieh Chaku,
you can close your
am I audible?
screen. Yeah, you are hearing.
Yeah, so my question is already answered, but I'm just asking about the resources, if I can get that resources. And your profile is also not on Google Scholar, so how can I email you or what about the
Yes, yes.
VIT on FPGA?
Yes, I'm writing my. Wait. Yeah. This is the name of my profile on LinkedIn. If you search this on LinkedIn, you will
Yeah,
find my
I already
profile.
yeah I already sent you
Yes,
a
yes. And
request.
my email is on my profile too.
Perfect. Yeah, so I can send you the email as well. Thank you so
Yes, yes.
much.
I will
Thank you,
have
guys.
to reach out. You're welcome. You're welcome.
Thanks a lot.
You're
So thank
welcome.
you, Jokar, and thank you everyone. I hope everyone have enjoyed this webinar. What do you think? Have you enjoyed?
It
Yeah,
was very interesting experience, and it's very valuable for me. I understand that your audience are very curious about the fundamentals, and they are very good listener, and they're interested in this field. I hope successful for all of them, and I hope that this session be useful for all of them.
and let me introduce innovative skills. Actually, uh, at this moment we focus on two different things. One is we have the fourth industrial revolution based edtech platform in our country. Like we focus
In
on
what? I couldn't
four
understand.
four IR, fourth industrial revolution. Okay.
Yes.
And besides that, we have some clients in 8 different countries like Saudi Arab, Denmark, South Korea, Malaysia, and we have some collaboration with some university for research work. Do you know? You can search like Noor Binti University in Riyadh, Saudi Arab. So we have do collaboration with them regarding in the area of AI, machine learning, computer visions, and that's why we are trying to expand our network with other industry expert like you. Okay, so
Thank you. That's so much.
we are really really lucky to have you in our webinar, as you are so much busy with your work. And also the audience, thank you so much for joining. Hopefully you will do good in the future. Your career will
Thank
be
you.
good, hopefully.
Thank you. Oh, oh, I can't hear you, Salman.
Maybe he got a
Oh,
problem, so we can wait for a while. Yeah, I'm his friend. Like, yeah.
okay,
So
okay. It was a problem in Salman's internet.
yeah,
Am I
maybe
right?
now his internet has big problems.
Okay, okay.
Like,
I thought that it was my issues.
no, it's fine. Sorry to keep you waiting. Yeah, thank you. Thank
No
you so
problem.
much for your wonderful presentation. I'm really pleased to know all the detail about like AI and also AI agent and yeah, different algorithm you introduced. Thank you so much for that.
You're welcome. It was my pleasure, and I'm very honored to have this opportunity. I hope to more collaboration and more being in touch and reaching out. And I hope the best with your career and your students and audience.
Yeah, sure. Maybe someone can make some uh, end talk like to complete the session, but he's not present yet. Yeah, we can wait for a while more.
I could not understand. We should be wait for Salman to return to the meeting.
I'm not sure, but
No problem. I will stay
then
here.
I'm sorry, it's actually already past
No problem. It's
in the time.
happened quite often. It's
Okay.
okay.
He's back.
Okay.
Sorry, sorry. Suddenly my
No,
internet restarted. Okay. Sorry, sorry.
no problem.
Suddenly my
No
internet
problem.
restarted.
I can understand. It can happen for everyone.
Okay. So thank you so much. So do you have anything to say to us, Mr. Jokar?
No, thank you. Thank you for giving me this opportunity. I enjoyed a lot. It was my pleasure. And I hope to have more opportunity to collaboration and keep in touch with your audience and your company.
Okay, okay. So I think this is end. We can end for today, and hopefully in future we can have you in another webinar, knowledge sharing sessions. Okay,
It
and
would
the
be,
audience, thank you for joining. I think we can say goodbye. Okay.
yes, yes. I should say goodbye and glad to meet you. And I'm very happy to have this time between you, interested people. And I hope you successful in your career.
Okay. Yeah, we can share the slide. No problem. Okay. Thank you.
Okay, okay. Goodbye. Have a good night.
Goodbye. Goodbye.
Goodbye.